Hey everybody, welcome to Module 6, and it is all about solving equations, just one-step ones. Learning targets, you will be able to solve one-step equations, and you're also going to be able to write and solve equations based on story problems. So let's get started. Some things to remember and to know from the last module is we studied expressions and we learned some vocabulary words. And I just want to remind you over here on the left-hand side is an expression. It's made up of terms, and those terms have coefficients, variables, and constants. And the terms are separated by the operation symbol. And what makes an equation different is an equation has an equal sign showing the relationship of two equivalent expressions. So here is an expression, and then here is another expression, okay? And equations just show that they are equivalent. So look for that equal sign to know if it's an equation or not. Otherwise, it's an expression. All right. So, writing and solving equations from visuals. So, mathematics is so visual. And when we're solving equations, it's helpful to think of like a balanced hanger as an equation. Both sides of the hanger are equal weights. So, if I look at this hanger here and I'm trying to make sense of it, I'm trying to think to myself, what's on the left side, what's on the right side, and know that they are equivalent to each other. So one thing, so if I'm looking at the left-hand side, we of course can think of that as x plus x plus x, or we can think of just three groups of x, and that side is equivalent to, there are weights labeled with 1, and how many are there? There are 6. Okay, so this hanger is showing 3x equals 6. With equations, we want to be able to, we'll write them from a picture or context and also be able to solve them. And what that means is we want to solve for the unknown or solve for the variable. And if I'm looking at the hanger, I'm trying to think of, well, if these are both equal sides and I'm looking at it like this, like an x is equivalent to two of those weights, then it helps me know or helps me figure out the value of one of those x's, because that's all we care about. We're trying to figure out the value of one of those x's. So going back to my equation, x would equal 2. Okay, each one is worth 2. And I know that because if I were to check it and actually, if I labeled each of them with 2, then the left side would equal 6 and the right side would equal 6. And so it's always good to kind of check it. Okay, looking at just the equation, that's like saying 3 groups of what equals 6? Well, 3 groups of 2. Okay, look at these hangers. Let's write equations to represent them and then solve for the unknown. Over here, we have a weight that's labeled y plus 3 more weights being equivalent to 6. Can you think through that? What would the value of y be to make that true? You're right. Y equals 3. Okay, let's check it. If that's 3 plus 1 would be 4, and then 5, and then 6, yeah, that would equal the other side's weight of 6. Okay, you could also think of it as, if I just wanted to narrow it down to this weight, if I were to take off these 3 pounds or whatever they are, then I would change the hanger, right? It would become unbalanced. But if I did the same thing to this side, I would even it out, right? It would be balanced. And then I can take a look at it this way and I could say, oh, the y by itself would then be equal to 3 weights over here. Okay, next one. let's take a look at this. Oh, okay. So 12 on the left is equivalent to a y plus y, or 2y. I'll just call it like that. Ooh, what do you think? If this side's 12 and it's balanced with two equal weights over there, because they have the same variable, y and y, then what's the value of just one of them? Yep, y equals 6. We can write it like this because, again, that equal sign is just showing us the relationship of it being equivalent. Okay, excellent. So an equation represents two equivalent expressions. I've said that before. If we know both sides have the same value, then we can think about it like a puzzle and work backwards to figure out the unknown, which is the variable. Okay, just like with the hanger problems, we can kind of look at it as a puzzle and try to reason through what the weight of one of those unknowns would be to keep it in balance. So let's just look at equations by themselves. This first one, x plus 3 equals 10. Well, you probably already know what that would be because you know how to solve this puzzle. You know what added to 3 equals 10. So x equals 7. How do I know? Plug it in and check. 7 plus 3 equals 10. Okay. So again, we're just reasoning through these ones, and then I'll show you in a second kind of how to do the steps. The second one, something and then take away 5 from it would equal -7. So if I'm thinking of like a number line almost, maybe this will help me, because again, visual helps me reason through. So I started off at an unknown point, and then I traveled left 5 jumps, and I ended up at -7. So -7 is like the ending point. Okay, so I'm going to work backwards. If I had this unknown starting point and I traveled left 5 jumps from it, that means if I'm going back in time, right, I would have jumped 5 to the right from here. Okay, 1, 2, 3, 4, 5. And this would give me like my unknown or my x. Well, what would that be? -7, this would be -6, -5, -4, -3, and -2. X equals -2 because I did 5 jumps from it. Okay, I'm working backwards, like I'm unraveling the puzzle. This next one, 2 groups of y equals -20. So I've got 2 groups of y, and the total is -20. So how much is in each of those groups? Yep, -10 and -10. That equals -20. And then this last one, we're starting with an unknown amount and we're dividing it into 3 equal groups. Okay, so I'm starting with like this unknown, this z. I'm cutting it into 3 equal groups. I'll just show you with a tape diagram underneath it. And in these groups, I have -9. So again, remember back to division. Here's our total or dividend. We're dividing it into the number of groups, and the answer, looking at it that way, would tell us the amount in each group. So then what's z? Z would be like all of those groups put together, right? With division, we always start with the total. Z would equal -27. So I just wanted to kind of point out some logical ways to reason through these. And drawing pictures helps, so don't be afraid to do that to help you kind of reason through an equation. But here is the official steps, right? We use inverse operations to solve equations. Inverse just means opposite. Okay, so read these with me. Step 1, in the expression with the variable, what operation is taking place and or what are the signs of the constants? That's just like a question we're asking ourselves. So here are the operations: add, subtract, multiply, and divide. Okay, so once we just to ask ourselves, so what is happening with the variable? And then step two is we want to think to ourselves, well, what's the inverse of the operation that's in the equation? And or how do I work backwards to get one variable by itself? So I want to do the opposite of what's there, kind of like you saw me do earlier, like working backwards. And then step three, always remember what I do on one side of the equal sign, I have to do to the other side of the equal sign to keep it balanced, just like the balanced hanger model. So let's put this into action. Here's our first equation here. X plus 2.5 equals 7.5. Okay, so in this expression, the operation that's taking place is adding. I start with an unknown, I add some more to it, and then I equal a total. Well, if I'm going to go backwards from that and relate it to the hanger diagram, so there's the beginning of the middle of the hanger. I want to unravel what was done to the X. So I'm going to take away the 2.5, right? I'm working backwards. And step three, what I do to that side of the hanger or the equation, I have to do over here. So I'm going to subtract 2.5 over on that side. So this 2.5, and then I take away the 2.5. Do you notice like I made it disappear? I just wanted the X by itself. And then I did that action on the other side. So I'm left with just the X on that side equals what's 7.5 take away 2.5. Yeah, 5. Okay. Okay, let's try this one. I'm going to draw my little line, balanced hanger. Okay, let me think about this. 6 groups of X. Okay, 6X. They're side by side. That means they're being multiplied together. So I have to unravel that, undo that. And step two, the opposite, the inverse of multiplication is division. So watch what I do. I'm going to show you division by using the fraction bar. Remember that? I'm allowed to do that. The fraction bar means division. 6 divided by 6 is 1, right? It's like 1x. That's what I want. I just want 1x all by itself. So I did division on that side, and step three, I just have to remember if I divided by 6 on that side of the hanger or the equation, I have to do the same thing over here. So I have x by itself, and it's showing me the value of x, or like the weight of that x on the hanger would be 16 6. Or we could turn it into a mixed number if we'd like. That would be 2 full groups, that's 12, 4 left over, 6, or 2 and 2/3. Okay, I'm okay with that. Okay, so 16 6, perfect. So step one, what operation is taking place? Step two, do the opposite of it. And step three, whatever you did in step two, do to the same to the other side. Draw a picture if it helps. Well, what about negatives? I'm not worried. It's the same thing because in step two, I'm going to scroll up for a second. It says, what is the inverse of that operation and or how do I work backwards to get one by itself? So I think I just take a look at the signs sometimes. All right. So here's my hanger. X started off with a number and then we took away 1.6 or 1 and 6 tenths weight. I want to get that to 0. So I'm going to do the opposite. I'm going to add 1 and 6 tenths. So that right there, that action cancels to 0. Remember opposites, negative 1.6, positive 1.6, 0, which I want because I want to get this guy by itself. So if I added 1.6 over here, I'm going to add 1.6 over here. And now I have to remember my rational number rules. Negative 8.2 plus positive 1.6. The signs are different. So in order to solve this, I have to subtract, but I know I have more negatives, so I'll just put that there for a second. Okay, so 8.2 minus 1.6. That's tricky, but again, I'm just remembering how to solve addition of negatives and positives here. Okay, so here I go. Borrow 1, Okay, so that'd be 6.6. So negative 6.6. Okay, how do I know if I got it right? I can plug it in and check. Negative 6.6, that's what I'm saying the value of the x is, minus the 1.6. In the original problem, I'm checking, does it equal negative 8.2? Yes, because negative 6.6 going further left on a number line 1.6 more times would land on negative 8.2 on a number line. See, squeeze this in. 6, 7, 8. There we go. Yay. Okay. All right, over here. Oh, okay. So on this side of the hanger, I have negative 4 groups of x, and then it equals negative 2. So I have to unravel and think through, the value of just one of those. Okay. I'm noticing that this smaller. I feel like this is going to be like a fraction because I'm just looking at the numbers and trying to make sense of that. Okay, negative 4 times x. The opposite, divide by negative 4. Cancels to 1 or divides out to 1x, which is perfect. That's what I wanted, 1x by itself. If I divide it by negative 4 over here, what do I have to do over here? You got it. Okay, you might be thinking, well, that looks funny. Think of it as a fraction because again, division is just fractions. So that would be a negative divided by a negative. That's positive. So 2/4 I'm fine with, or if you want, you can call it a half. Okay, story problems. Last learning target here. Olivia purchases gifts for her mom and grandma for Mother's Day. The first pair of sunglasses um, there's a little typo, sunglasses are $16.35. And the second gift is a bracelet. So her total is $39.75. How much did she spend on the bracelet? Okay, what is our unknown? Is the cost of the bracelet. I'll call that X. Why not? So unknown is the cost of the bracelet. When I'm looking at a word problem, I'm just kind of taking each piece of information one thing at a time. So I'm imagining like playing a movie in my head, which is always kind of a good idea, just like you do when you're reading. She purchases gifts for her mom and grandma. The first pair of sunglasses are priced for $16.35. So that's the first gift she buys. And then the second gift is a bracelet. Oh, so then she buys a bracelet. Do I know the cost of the bracelet? No, I'll call it X. And her total is $39.75. Okay. And then from here, I'm trying to unravel this problem, right? And in order to figure out the unknown here, I would use subtraction because one gift plus the other gift is a total. So to work backwards, I use subtraction. Okay. And then you can go ahead and do that. And then because again, I want to just show you how we write the equation for the story problem. Okay. Notice the variable is within the equation. It's not by itself yet. That's what I do when I solve it. Let's take a look at this last one. Micah and two of her friends evenly split the cost of a meal. They determined that each person owes $14.68. How much was the entire cost of the meal? That's my unknown. So y will equal the cost of the meal. Okay, so I'm imagining this as like a movie or a little clip. Micah and two of her friends. That's 3 people. And they share the cost of a meal equally. Okay, how much was the entire meal? Well, that's kind of the beginning point, right? If I'm sitting around the table with my friends, we get our bill and it reads whatever it is, right? So why? That's the total cost. Well, each person owes $14.68. But if the cost was evenly shared among 3 people, that's division, right? We're going to take the cost, we're going to divide it among 3 of us, and we know that that equals $14.68 for each of us. So, how do you work backwards to figure out what it started as? Right, we have to multiply. And again, going back to the steps, do you see how this is division? To unravel that, we use multiplication. So to solve it, just a side note, we would have to do 1468 times 3, but we're not going to solve it because again, this is all about how do we write the equation that represents the story problem. And we'll do more practice together. But just think of it as a little movie and you're just going one step at a time trying to figure out where the unknown kind of occurs in the equation and then writing it out. Okay, hope that helps.